9 miles down, pressure can crush steel in seconds. No sunlight has ever reached that depth. In 1960, a Swiss engineer and a young Navy lieutenant took an untested steel ball into that darkness anyway, in a craft never built to survive a broken window. Partway down, the window cracked. They kept going. What they found down there still gets argued about today. On January 23, 1960, Jacques Piccard and U.S. Navy Lieutenant Don Walsh climbed into a steel pressure sphere attached to a vessel called the Trieste and began their descent into the Mariana Trench. The Trieste was a bathyscaphe, a type of deep diving craft built like an underwater blimp. A massive tank filled with about 130,000 liters of gasoline floated above the crew sphere, since gasoline is lighter than water and could lift the vessel back to the surface once the dive was done. Piccard and his father had designed the vehicle together, and the U.S. Navy bought it in 1958 to explore depths no person had ever reached. About 30,000 feet into the drop, the outer window of the vessel cracked from the pressure outside. Walsh and Piccard felt the whole submersible shake around them. At that depth, a cracked window does not mean a slow leak. It means the glass could fail completely within seconds, and there would be no way to survive what came rushing in after that. They kept sinking anyway. Turning back that late in the descent offered barely any advantage, since rising back through miles of crushing water would take almost as long as continuing down. They touched bottom at 10,911 meters, deeper than any person had ever gone, and stayed only 20 minutes before the damaged window forced them back toward the surface. During those 20 minutes, Piccard and Walsh reported seeing what looked like a flatfish resting on the seafloor beneath them. Scientists have argued about that sighting for decades since, because almost nothing was expected to survive at a depth where water pressure could flatten a truck many times over. Nobody has ever fully confirmed or ruled out what the two men said they saw. That single dive proved a person could survive a trip to the bottom of the ocean. It also proved how little room for error existed down there. The two men who felt that window crack came close to becoming the first people lost at the deepest point on the planet, with nobody even able to reach them if something had gone wrong. For decades afterward, almost nobody returned to try again. Building something that could survive that kind of pressure was expensive, slow, and offered no guarantee of success. It would take a very different kind of machine, one with no crew inside it at all, to finally go back and stay long enough to actually study what was living down there. In March 1995, a Japanese robotic vehicle named Kaiko became the second craft in history to reach the very bottom of the Mariana Trench, touching down at 10,911 meters, matching the depth the Trieste had reached 35 years earlier. Built by the Japan Agency for Marine Earth Science and Technology, Kaiko carried no crew. It was lowered from a ship on 2 connected cables, with cameras built to survive pressure that would flatten a truck. The vehicle weighed over 10 tons and needed both a launcher and a separate diving unit working together to reach that kind of depth safely. Between 1995 and 2003, Kaiko completed more than 250 dives across the world's oceans, and more than 20 of those reached all the way to the floor of the Mariana Trench. It collected sediment, filmed crustaceans and worms living in total darkness, and pulled up bacteria that scientists later studied for possible use in medicine. In 2000, the same vehicle discovered a completely new hydrothermal vent system on the floor of the Indian Ocean, and a year earlier, it had located the wreckage of a failed Japanese rocket launch sitting on the seafloor near the Ogasawara Islands. Then, on May 29, 2003, while working in a different part of the Pacific during a typhoon, the secondary cable connecting Kaiko to its launcher snapped. The steel fibers inside that cable had quietly weakened over years of bending under extreme pressure, and the failure point finally gave way all at once. Kaiko sank and was never recovered. Japanese researchers searched the surrounding waters for weeks afterward, but the vehicle that had visited the deepest place on Earth more than 20 times was simply gone. That loss meant the most experienced deep trench vehicle on Earth simply vanished, cable and camera together, with no clean explanation available in the moment it happened. It would take a new generation of machines, built specifically to stream live video back to the surface, to change how this kind of signal loss actually played out. In 2008, the Woods Hole Oceanographic Institution finished building a vehicle called Nereus, designed to work either on a thin fiber optic tether or completely on its own. Students and researchers across the country suggested names for the project through a nationwide contest, and the winning name came from a Greek sea titan described as having a man's torso and a fishtail. Engineers built the vehicle with several features nobody had tried before, including lightweight ceramic flotation material and lithium-ion batteries strong enough to survive the trip down and back. On May 31, 2009, Nereus became the third vehicle in history to reach the bottom of the Mariana Trench, touching down at 10,902 meters. This time was different from every earlier trip. Nereus stayed on the seafloor for more than 10 hours and sent back live video the entire time, letting scientists on the ship above watch the bottom of the ocean unfold on a screen in real time, instead of waiting for a vehicle to resurface with recorded footage. It also explored the deepest known hydrothermal vents on Earth, hot underwater springs found along the Cayman Trough in the Caribbean. Nereus had a return trip to the Mariana Trench scheduled for November 2014, part of a bigger research plan called the Hadal Ecosystem Studies Project, built to study how life survives in the deepest, coldest, most crushing parts of the ocean. That plan changed only a few months earlier, in a way nobody expected. Before Nereus could make that second trip back to the Mariana Trench, something happened in a completely different trench that ended its career for good, and it happened in front of the very team that built it. On May 10, 2014, 30 days into a 40-day mission, exploring the Kermadec Trench near New Zealand, Nereus was working at a depth of 9,990 meters when communication with the surface simply stopped. About 7 hours into what was supposed to be a 9-hour dive, the video feed cut and every signal from the vehicle went silent at once. Just minutes earlier, the vehicle had finished collecting a sea cucumber for one of its onboard experiments and was getting ready to head back toward its recovery platform. For a stretch of time after that, nobody on the ship knew exactly what had happened. Standard emergency recovery signals got no response. The crew began searching the surface nearby and eventually spotted floating debris in the water. Once recovered and identified, that debris confirmed what everyone had feared. A portion of Nereus had imploded under pressure, reaching 16,000 pounds per square inch, more than 1,000 times the pressure felt at sea level. Nereus was gone, and along with it went the plan to send a live camera feed back into the Mariana Trench that November. Woods Hole's research director called the loss a reminder of exactly how much risk comes with working at that kind of depth, risk that no amount of engineering experience can fully remove. A biologist who helped design the vehicle said it had let researchers ask questions about the deep ocean nobody had even thought to ask before. Before we move on, if you're enjoying this analysis, please consider subscribing. It helps the channel tremendously. With the one vehicle built for live streaming video now sitting in pieces on the Kermadec seafloor, the team preparing for the Mariana Trench mission had to change their entire approach, and that change is exactly what set up the next strange moment. With Nereus lost, the Schmidt Ocean Institute switched to a completely different kind of equipment for their planned trip to the Mariana Trench later that year. Instead of a tethered vehicle sending back live pictures, they built landers, boxy frames about the size of a large refrigerator, packed with cameras, sensors, and baited traps, designed to sink on their own with no cable attached at all. The team used 5 different landers for this mission, each built for a different job. 2 carried baited cameras meant to attract animals close enough to film and identify. Another was fitted with a reinforced trap built specifically to survive crushing pressure while catching live specimens. A 4th carried steel grabs for collecting rock samples, and a 5th used long tubes to core into the mud and measure how active the tiny community of worms and microbes living inside it really was. These landers dropped freely through the water toward the Submarine Deep near Guam, one of the deepest sections of the Mariana Trench, sinking to depths approaching 11,000 meters. Because there was no tether, there was also no live video feed. Nobody on the ship above could watch what was happening in real time. The team simply sent a lander down, waited, and later triggered an acoustic signal that released weights so the lander could float back up on its own. This was not a mistake or an oversight. It was the only realistic option after losing the one vehicle capable of live streaming from that depth. But it also meant that if anything went wrong 9 miles down, nobody would know until the lander either returned or failed to return at all. That gap between sending something down and finding out what happened to it is exactly what turned an ordinary science mission into a genuine mystery for a few tense hours. Several landers were sent down together into the Submarine Deep. Each one used thick glass spheres filled with air for buoyancy, strong enough in theory to survive the crushing pressure at the bottom of the trench. Every lander also carried steel weight plates, up to 14 of them, that could be released later to let the frame rise back toward the surface once its work was finished. On this trip, one of those glass spheres did not survive. The glass cracked and imploded in a fraction of a second, and biologist Jeff Drazen of the University of Hawaii later compared the failure to a stick of dynamite going off underwater. A hydrophone nearby captured the sound, and in the freezing, pitch-black water, that shockwave kept echoing along the trench walls for a stretch of time afterward. One of the deployed landers did not make it back to the surface at all. For the team above, this was the same uncertain moment Woods Hole had faced with Nereus months earlier, just on a smaller scale. A piece of equipment went silent 9 miles down, and there was no way to know immediately whether it was pressure, a mechanical fault, or something else entirely until the wreckage or the surviving equipment could be examined. What made this moment different is that most of the other landers sent down that same day did survive. And when the team pulled them back up, what those surviving cameras had actually recorded turned out to be worth every bit of the risk. The baited traps on the landers that did return were swarmed by shrimp-like scavengers called amphipods, some measuring only a few centimeters long, that stripped clean anything the larger animals left behind. The cameras also recorded something even rarer swimming past. A pale, wide-bodied fish with wing-like fins, an eel-like tail, and a strange scalloped face appeared on camera at a depth deeper than any living fish had ever been filmed before. Researchers Mackenzie Geringer, Thomas Lindley, Alan Jameson, Erica Gutze, and Jeff Drazen studied the footage and specimens closely, and in 2017, they formally described it as a brand new species in the scientific journal Zootaxa, naming it Pseudoleparus suirae, now commonly called the Mariana snailfish. Like other members of the snailfish family, it has no scales and a soft, almost gelatinous body built to handle pressure instead of resisting it with a hard shell. It remains one of the deepest living fish species ever confirmed on camera. Scientists already knew part of how fish like this survive pressure that would crush a human instantly. A natural chemical called trimethylamine oxide builds up inside their cells, keeping protein stable and stopping them from getting crushed or broken down by the surrounding water pressure. Researchers have noticed that fish living deeper and deeper carry higher and higher amounts of this chemical, almost like the ocean has a built-in limit on how deep a fish can survive based on how much of it a body can hold. It explains part of the picture, but not all of it. and researchers are still studying exactly how life manages to thrive in a place with almost no light, freezing cold water, and pressure beyond anything humans experience anywhere else on the planet. None of this happened because a monster attacked a camera or because anyone deliberately cut a signal. Every explanation here comes from recovered debris, hydrophone recordings, and published research. But there is one part of this story that no amount of later evidence can fully erase. At the exact moment a camera or a signal cuts out 9 miles down, the people on the ship above genuinely do not know why. Not because they are hiding something, and not because a creature is lurking near the wreckage. It is because sound and light barely travel at that depth. Cables and hydrophones only tell part of the story in real time, and the full answer usually only comes later, once debris is recovered or a lander finally floats back to the surface. That gap between the moment a feed goes dark and the moment scientists actually learn why is real, and it happened more than once in the history of exploring the Mariana Trench. A cracked window nearly stranded 2 Navy men at the bottom of the ocean in 1960. Kaiko vanished in 2003 with no warning. Nereus went silent in 2014 and left only floating debris behind. A lander's glass sphere shattered in the Serena Deep that same year, its dying sound recorded on a hydrophone. Every one of those losses eventually got a real explanation grounded in physics and engineering. But for a stretch of time before that explanation arrived, the people running these missions were left staring at a blank screen or a cracked window, knowing only that something 9 miles down had just gone wrong. And the fish that finally swam past a surviving camera that same year reminded everyone why they kept sending machines, and once, 2 men, down there in the first place. If this kind of deep ocean mystery is your thing, subscribing helps more of these stories reach you the moment they come out.